I'm back and I'm on the next page. Just a couple things. Very similar to the things that we talked about in class today. Linear, quadratic, cubic, quartic, and quintic functions are polynomial functions. So these are in order of degree. 1, 2, 3, 4, and 5. You will have to know those names. The degree of a polynomial function is the highest power of the variable in the equation. So this would be degree 5 because the x to the fifth is fifth. The coefficient of the highest power of x is the leading coefficient. So in this case, the leading coefficient would be a positive 3. When you take a look at this chart, a few things. Degree 1 is called linear. 1 is an odd number, so we call it an odd degree polynomial. And you'll notice that if the leading coefficient is positive, it goes up and to the right. If the leading coefficient is negative, it goes down to the right. And you'll notice also for the odd functions that if one side goes up, the other side will be going down at the end. So they're opposite. Here is an even degree polynomial. 2 is quadratic. If the leading coefficient is positive, in this case it's 2, you notice it's up, up. If its leading coefficient is negative, for even, they're both going the same direction, so it goes down to the right and thus down to the left as well. Cubic is a degree 3. It's odd, so they're going opposite directions at the ends. One goes up and one goes down. You notice what I said about turns before. So here the number of legs is 1, 2, 3, or the number of turns is 2. In this one, it's a little bit harder to discern, but perhaps here's a turning point. There could be a local maximum just right around there. So it went up and then it comes down just a little bit, and then it comes up again. So here there could be 2 turning points, but you could actually have only 1 turning point. If you just had straight y is equal to x cubed, instead of 1, 2, 3 legs, you could just have 1. And actually not even a turning point, it was just kind of come up, swivel to the right and come back. It's called an inflection point. So you got to watch if you're counting the legs. If it's cubic, it doesn't necessarily have 3 legs. It could just kind of have 1 leg. I think there's a nice example of here, yeah, with the degree 4. So if we count 1, 2, 3, 4 legs, but here is an example where we really only have 1, 2 legs, right? It gets kind of weird curvy here, but really there's only 1 turning point and 2 legs to that. So when you think about degree 4 should have 4 legs and 3 turning points, you should really be thinking a maximum of 4 legs and a maximum of 3 turning points. But again, this is indicating looking at the leading coefficient here, it's positive, and so it goes up to the right because it's even. It goes up to the right and to the left. Here the leading coefficient is negative, so it goes down to the right, and because it's an even degree polynomial, they're both the same. Quintic, odd, positive leading coefficient goes up to the right, and negative leading coefficient goes down to the right. Here let's count the legs. It's a degree 5, 1, 2, 3, 4, 5, but here it's only, what could we say, 1, 2, 3. So it has a maximum of 5 legs. In this case, it only has 3 legs. So that's what happens sometimes. You should be able to understand or know this chart, and you should know the words quartic and quintic, for example. This is describing in words exactly what I was talking about. Just to read this, as x approaches negative infinity, the graph falls to the left, and as x approaches positive infinity, the graph rises to the right. So this is an odd degree polynomial. So for example, here's the odd degree polynomial. As x approaches positive infinity, as x gets larger to the right, y increases. So that's what they're describing, that behavior over there. Talking about local maximums and local minimums, or another word I was using was turning point, and this is stating explicitly what I said before. An inspection of the graphs of the polynomial functions in this lesson and in the previous one illustrates that the graph of a polynomial function of degree n can have at most n x-intercepts and at most n minus 1 turning points, local maximum or minimum points. For example, the graph of a cubic function can have at most 3 x-intercepts and at most 2 local maximums or minimums. So here's an example of a degree, it's probably of degree 1, 2, 3, 4, and it has 3 turning points. In this case, 2 maximums and 1 minimum. Pardon me. Let's take a look at example number 1, and then I'm going to get you to try the check your understanding after that. Example number 1 is using a table of values to sketch the graph of a polynomial function. So we're going to use a table of values, but we're also going to be a little bit aware of this new stuff that we know about what order the polynomial is, whether it's odd or even, and what the leading coefficient is, and that will inform our sketching as we make our table of values. So looking at this first one, it's cubic, and the leading coefficient is negative, and looking just at their solution, it kind of makes sense. So if it's negative, that means it's going down to the right. Since it's odd, since this number is 3, it goes up to the left. So it's got that difference. If it's odd, they go different directions. If they're even, it's going the same directions. And then I guess the trick to this whole piece is picking good values of x. So -2, -1, 0, 1, and 2, and they just plug it in there and they get their answers. So getting a sense, first of all, of what the basic shape is going to look like, and then plugging in your numbers. Pardon me. For part B, let me get my drawing in here. For part B, when I'm looking at this, the first thing I see is like, hey, I've got x to the fourth, x to the third minus 3x squared. It looks to me like I can quickly factor out an x squared, and then when I do that, I get x squared minus x minus 3. And is it possible to factor that, this part? Two numbers that multiply out to -3 and add up to -1. Oh, no, it doesn't work so well, because I could do -3 and +1, but that would give me a -2. So this doesn't factor out nicely. But I do know that I'm going to get 0 is going to be one of my x-intercepts. In fact, since it's x squared, I'm going to just tell you ahead of time, we're going to get what's called a double 0. So just to do a cross here. So here it is where x equals 0. It's going to be crossing there, or we'll have a 0 there. Normally, when we have an x-intercept, it crosses the x-axis somewhere, right? But if this is a double 0, because it's x squared, it's going to be touching but not crossing. So it's kind of like when you have y equals x squared all by itself, it touches but doesn't cross. We're going to have that kind of behavior here. So thinking overall, this is a 4th degree, it's even, and the leading coefficient is positive. So without even looking at any of the answer, I kind of know it has this shape here, right? It goes up, and I'm guessing it does kind of something like that. I don't know, where it touched but not crossed over here. So this is sort of my guesstimation of what it's going to look like. I know for sure that it's going to have this up and to the right and up and to the left, and I know that it's going to be touching but not crossing at the origin. I could be wrong on the general shape of it. It could be kind of more like this, however. It could be touching and crossing here, would be another example, and we could still have that general shape, right? There would be another option of where it touches but doesn't cross. Here it comes from positive, touches, and then goes positive again. And that's just thinking about this x squared term. I'll be talking more about that later. Let's just cheat and take a look at what they have for the answers here. If we scroll to the next page. Here's what it looks like. So we've got the up and to the right and up and to the left. And here, yeah, we have that touching but not crossing at the origin. So, you get the basic sketch, and they plugged in a bunch of values for x, and what they started was -1, -2, 1, 0, 1, 2, and 3. Where did these numbers come from? Well, we didn't really do the work, but they plug in those values of x for each of these 3 terms. So they say, let's say x is -2, they would say -2 to the 4th minus -2 to the 3rd minus 3 times -2 squared, and so on. So for the check your understanding, tell you what, I will do 1A for you, and I'd like you to do 1B. So looking at 1A, so it's cubic, it's of degree 3, and the leading coefficient, so cubic, and the leading coefficient is positive. So sort of the general shape of this is going to be probably something like this. Oh wait, no, cubic and positive, let me erase that. That would be an even because it's going up to the left. Kind of more like this. Okay, some form of this shape. That's what cubic and positive look like. Or if it was just straight y equals x cubed, it's possibility of it kind of going like this as well. So this is 2 turning points, and this would be 0 turning points. But it's probably something of this one, because it's not y equals x cubed all by itself. Looking at it, I can factor out an x squared. So if I said y equals x squared multiplied by x minus 3. So here are my zeros, my x-intercepts. I've got a double 0 at 0. Okay, so I'm just going to put a double 0, which means that it's that touching but not crossing idea. And here I got my x equals 3. So when I draw my sketch here, 1, 2, 3, so it crosses there. So making it look like this, it crosses there. Okay, it comes down, and now it's got a touch but not cross. So I think it's going to go like this, and then like that. So that's going to be my basic sketch. And really, like, this is sketch. You don't have to be exact. So I'm pretty well good to go if I put a 3 here, put a 0 here, and put a 1 there. What I don't really know is, like, where's this minimum? It would be nice to know, and have a few other pieces of data. So I should really make a table of values like they do here. So I'll put x. I can put, I'm tempted to put y on this side, but technically it's f of x. So if we put a negative 1 in here, negative 1 cubed is negative 1 minus 3 times negative 1, so it's negative 1 minus 3, so it'll be negative 4. If I put a 0, I get a 0. If I put a 1, I get 1 minus 3, so it's minus 2. If I put a 2, 2 cubed is 8. Minus 3 times 4 is 12. 8 minus 12 is minus 4. 3 I know is going to be equal to 0. I'll use a different color just so it shows up. So 0, 0, that's that dot here. Negative 1 and negative 4. So I'll just label that spot. 1 and negative 2. 2 and negative 4, and 3 and 0. So my sketch is okay. It's not great, but here's the table of values, and there's the basic shape. So that's really all I'm looking for. B is a little bit harder in that it takes a little bit more effort to make your table of values, but I'd like you to go ahead and give that one a try. Thank you.